Hello everyone and welcome to my new video on this channel, Free Code School, where I aim to teach Python programming to everyone. So I do not only aim to teach Python programming here, other than Python programming, I also aim to teach data structures, algorithms, and a lot of other computer science subjects here. So computer science is a vast field. So I will look into that into details in this video. Like this video is itself on basics of computer science. So I will cover about like what are all the important subjects in computer science. Like programming is one of them, but there are many other subjects also. So I will discuss about them in this video. And in my last video, which was the first video in this channel, on this channel, I discussed about why one should learn programming. Like what are the reasons? I gave different reasons on why you should learn programming. So if you have not watched that video, I will request you to go and watch that video also because it will give you reasons like why you should learn programming, why you should learn to code, right? You will get some reasons there. And maybe that may inspire you to maybe learn programming, take programming course or learn programming. So let's see like what I covered in my last video. So in my previous video, I covered about, okay, before I go on to like the topics for this video, let me just, I mean, I have a request for you that do subscribe to my channel so that you keep on getting contents from my channel. So I'll be teaching Python programming here, data structures in Python, algorithms in Python, and maybe in future I may also cover other different subjects on my channel. So do subscribe to my channel if you want to get the content from this channel, like whatever videos I made and upload here, it will go to you and you can basically watch that video and learn a lot. Okay, now let's move back to this video. So in my previous video, I discussed about why you should learn to code or why you should learn programming. So the three reasons I discussed was one is of course job. I mean like for 80 to 90% of the people, it's like job. They want to get a job in the IT industry. So learning programming and not only programming, but learning programming is one of the first steps in like computer science, I will say. And then you have data structure algorithms also. So if you practice this well, learn this well, right, you can get a very good job in IT sector. Other than that, other reasons were that like the programming or coding, right? If you do this, it also increases your ability to think. What I mean by that is, let's say you do maths. So how does maths help you, right? So maths help you in solving problems and developing your thinking ability. Similarly, it's programming. Programming also helps you in solving problems, right? And it helps you in like increasing your thinking ability. The last reason I gave you is that what can happen is once you learn programming, once you learn coding, what you can do is you can convert. So you have some ideas in your mind, right? So that idea you can convert into reality with the help of coding. You can maybe develop a website for your idea. It's not about just about website, right? You can design different tools, right? With the help of your coding skills, you can design different tools that can help a lot other people, right, in real life. So that is also one of the important reasons. So think about Facebook, YouTube, right? All these are, I mean, a program basically, right? Running somewhere. Somebody has written this program. And these have transformed the life of like many on this earth, right? So you can also do the same in the future. So what is the plan ahead for like this channel, right? So of course, I will start with the Python programming first. So from the next video itself, I will start from the Python programming. I will teach you the basics of Python programming and how to write code in Python programming. Then I will move on to data structures in Python and at last algorithms in Python. Because just learning programming is not the end. I mean, it's just the beginning of like in the computer science, it's just the beginning. You also need to learn data structures and algorithms if you want to like maybe if you want to get a good job or other things also, right? If you want to convert ideas into reality or for thinking ability, you need to focus on data structures and algorithms also. And of course, do not forget to subscribe to my channel to keep getting these updates from my channel. Now, okay, so what you are going to learn in this video, right? So let me just give you a brief, like a brief overview of what you are going to learn in this video. So here first, I will start with what are the different parts of the computer, that is hardware. Then I will tell you about types of computer that are there. So these are very basic. I mean, it's like I'm just teaching you the very basics of computer science. Like I mean, what are different parts of computer, right? And what language does the computer understand? And what are the different programming languages? And what is compiler? What is interpreter? And I will discuss about all of this. And what language actually the computer understand, like the binary language. I explained about like how it understands that. Then I will after this I will discuss about like I will give you overview of what is algorithms, what are data structures, what is operating system, what is networking, and what is computer networking. And at last, what I will do is I will connect all of this. I will connect programming, algorithm, data structure, operating system, networking all together. Like basically, when you start coding, you will see that you will basically connect to each of this once you start coding. Now, okay, first let me start with what is computer science. So this is very important, Ivan. So you will think that, okay, I understand what is programming. So you're writing some code, right? That's programming. But then what is computer science, right? So you will always hear, right, in college and if you go to college, you get a computer science degree, right? You do not get a programming degree, right? So what is computer science? So computer science, if you see, right, it's the study of computers basically, and both hardware and software. That's computer science for you. Now, other than that, so this is the simple definition which you will find on Wikipedia or anywhere. But other than that, so of course you learned about how to communicate with a computer. So you know how to communicate with humans using languages, but you need to learn a new language. That is how to communicate with the computer itself. That is with programming language. Now, is computer science just about programming? I will say no, it's not. Programming is just the beginning of computer science, right? There are many other subjects in computer science that are very important. Like I took a computer science course in my college, and like I had 8 semesters, right? And I mean, I had like 20, 25 or 30 subjects, right? That I had in, like, you can say, like in every semester, I will have maybe, I think, 5, 6 subjects, right? So in 8 semesters, you will get around 40 subjects total, right? So it's not just about programming. Programming was just one semester for me. I mean, it was just one of the subjects for me. And there were many other subjects also. So of course, data structures is important. Algorithms are important. Compilers are important, like compiler design. Other than this, computer networks is important. Database is important. Machine learning in today's world is important. So these are some of the important subjects of computer science, right? Don't think as programming is just programming is computer science. It's just a part of computer science. Now, okay, first I will just start with a very basic assignment. Let's say you do not understand anything in computer science, nothing, you do not understand about, even about computers, you do not understand. Okay, you are using computers, but you do not understand what this mouse is, what this keyboard is, like you don't understand this. I'll just start with the very basics of this. So you have you have hardwares and softwares, right? So I will easily differentiate them. So what are hardware, right? So hardware are something that you can touch. So on your system, right, you can touch your monitor, you can touch your monitor, your screen you can touch. You can of course touch your keyboard. And if you have a CPU, physical CPU, you can touch that, right? Of course, the CPU is physical. I mean, I will show two different diagrams of CPU after some time. So, I mean, today you have laptop. You do not see the CPU there, right? You do not see it. You see the keyboard. You see the, monitor, but you do not see the CPU. But if you remember in the old times, like if you had a desktop systems, right? On that you can see the CPU also, right? Now these are called hardware device. Mouse, keyboard, CPU, monitor, everything is your hardware device. You can touch them. But software is like they are actual programs actually. So they are, you cannot touch the programs. So they are stored there on some hardware device, that is disk, or in the main memory. They are stored there. You cannot go and touch them. So you cannot touch them. That's the difference actually between hardware. So you see hard and soft, right? That's where difference comes there. And a software, of course, software cannot run without hardware. So if you want to run program, you will run it on your system. And your system has memory, your system has CPU. So a program needs memory, CPU, all of these things to run. And in computer science, we will mostly concentrate on the software part and not the hardware part. So we will not concentrate on like how your CPU works, how your keyboard works. So we will not discuss about all of this. We will mostly focus on like about the software part, how this program actually works, right? And how this program actually runs, how you can write this program, right? All of these we will discuss in the computer science, like all of the videos that so moving on to next, if you see, okay. So first let me, of course, I have given the example of hardware devices. So in hardware device actually, so you do not have like, you have like different segments of hardware devices. You have different types of hardware devices, right? So you have input devices, you have output devices, you have CPU, central processing unit, and then you have memory. All of these are like your hardware devices, but they are different segments of this. So let me explain all of these like segments separately. So what are input devices, right? So these are devices through which you provide your input. So you have to provide the input to your system. So how do you provide this input? You use the input devices. Some of the famous examples of input devices are keyboard, mouse, microphone, and webcam. Of course, through keyboard and mouse, we already provide the input, right? If you have to write something into the text editor, you use keyboard for that. When you are playing games or for other different purposes also, you use mouse, right? You use a cursor of your mouse to like open different applications, do the movements during games. When you play games, you use that to control the movements. So you have microphone for audio input, webcam for video input. So these are all examples of your input devices. Now moving on to the, okay, for every of these devices, like I'm mentioning here, I will also compare that with a human, right? So in human also we have input devices. Think about your mouth, right? Through your mouth you're eating your food. So you're, I mean, taking some inputs, right, through your mouth. That's the food. You have nose, right, that you are using for breathing. That's also, I mean, nose can be used for both, right? I mean, it can be also used for inhaling and exhaling, right? So for both it can be used. Like you breathe in, you breathe out. So when you're breathing in, it's like an input. When you're breathing out, it's like an output. Ear also you are using for listening, right? So that's again an example of input devices. Hands also is the input device mostly, right? You use hand for doing different activities, right? So that's also input there. Now let's move on to output device. And in every of this device, I will take examples of human beings, right? For human beings, what are the examples of output device? So let's see for system first. Like output device is anything which gives the output, just the opposite of input device. So through monitor, you get the output on your screen, right? Whatever you do, you see the output on this your screen. That is monitor. You have the printer also. That's the output device because you print something through your printer and you get an output there. Headphones and speakers also, if you see, are output, right? So some audio you are listening, that's coming from your system, right? So that's again a output, if you see. Like if you see, there are projector is another example, headset is example, plotter, there are different examples. I have taken some of the famous examples here to explain you what are output device in a computer system. Now, if you compare this to humans, I will say, of course, mouth, as I told you, you use the mouth also for speaking purpose, right? You are using mouth for eating also and for speaking also. When you use mouth for eating, that acts as an input device. And when you use mouth for speaking, it's like an output device. Similarly for nose, as I told you, when you are breathing in, it's like an input. When you are breathing out, it's like an output. Now, the next important, I will say, part of your system is central processing unit. And I will see this is one of the most important part of your system actually. This, again, you cannot see this part. See, I told you, hardware device, you cannot see all of the hardware device. Now, this is the brain of the computer, right? So, as I told you, this is the most important part of the system. This is the brain of the computer. So, you have brain, right? So, that's the most important part of your human body, right? Similarly, here, CPU is the brain of the computer. What it does is, so whenever you write program, right, you are writing some code, you're writing some program. The program is basically a set of instructions. And who will execute these instructions? So that CPU. CPU will execute all the instructions that you write in your code. Like it will do the addition, multiplication, decision making. So all of this will be done by, so your brain actually does all of this, right? It does the decision making, and like if you want to calculate like 2 plus 2, of course brain will help in that, right? Similarly here, CPU will help in all of these calculations. And also if you have, when you are giving input to your system through your keyboard, it actually first goes to the CPU. Everything goes to the CPU first, that's the brain. And from the CPU, then it goes to somewhere else. That's different. But everything first goes to the CPU. Even for output also, it goes through the CPU to you. I mean, everything is controlled by CPU. It's the brain of the computer system. Now, okay. Now, which one is CPU, right? As I told you, right, CPU, normally the left hand, right, the left figure that you see on my screen, right, that will come into your mind if you hear of CPU. But that's not typically CPU. Central processing unit is actually the right hand side. What you see is CPU actually. That's the kind of chip, right, electronic chip that you see, right? That's actually CPU. But since that chip is normally there in that box, right? So we normally call it as CPU. Because I told you, CPU is the most important part of the system. So that's why that box is also called by CPU. But there are many other also components also. There are many other hardware components in that box actually, right? But we call it CPU. But CPU actually is a electronic chip that you can see on the right hand side here, right? So that's the actual CPU. Now, okay, another important one, CPU is important, but along with CPU, Another, I will say, hardware device that is very important is memory. So of course you cannot again see the memory, it's a hardware device, but memory is used for storing and accessing the data. So when you write program, you have a lot of data in the program. You use a lot of data, you store a lot of data, you access a lot of data in the program. So when we go to actual Python programming, you will see that everything is data there. I mean, so you will see that how we are storing those data. So all those data will be stored in memory, and you will be fetching that data from the memory itself. Let me give you a simple example to understand memory. So when you are writing something in a text file, right, text editor or PowerPoint, right? So when you're writing something there, so it has to be stored somewhere, right, on your system. So that's where it is actually stored in the memory, right? That's where it's stored. This data is stored in the memory. So you have different types of memory. So you have main memory. So that's RAM, random access memory. So that is the fast one of the fastest. So you see, you have like different types of memory, and the speed of this is different. Like the speed, like for accessing. So of course, if you store something on the memory, you need to also access that, right? So at some time. So the accessing time for like different types of memory is different. Like main memory or RAM is very fast. You can access from there, from that part of memory very fast. Then you have disk memory. So disk memory is very slow. That's normally, I mean, also it depends on like if you want to store temporary or if you want to store permanently. So mostly what you will do is if you want to store some data temporary, right, you will store that on main memory. That is RAM. But if you want to store some data permanently, so if you create a PPT, so you want to store PPT for like long time, right? You do not want, let's say if you switch off your system, you do not want the PPT file to be lost, right? Whatever you have written there. So you will normally store that on the disk that is used for permanent storage. Now, of course, it also depends on the cost, right? Like the main cost of main memory, if you go and buy main memory, that's the hardware basically. If you go and buy that, the cost of that will be high compared to disk memory, because disk is like cheap in compared to main memory, because disk is normally used for just permanent storage. Main memory is used for temporary storage, and it's very fast. So the more faster the memory, the more the cost of that memory will be. Now, I will let me show you some diagram here. So I mean, you have four diagrams here. So let's consider the first diagram. That is this one, right? The first diagram, this one, right? So this is actually your memory chip, right? So that's the RAM actually. So that I told you, right? It is used for temporary storage, and it's very fast and it's very costly. So that this is your kind of RAM here. Now this one is your disk, right? So this is quite slow actually, and the cost of this is also low compared to the RAM or the main memory. And normally, if you see, I mean, now you will ask where these are stored, right? So of course, these are if you have this type of desktop here, it will be there in this CPU which you call that I told you. And if you have a laptop, of course, every hardware device is here, right? In this box you have, right? This is a small box. You have it like CPU and everything, RAM, everything is there inside this small box. Now let's take the human analogy. Of course, I told you that CPU is, of course, I mean, brain of your, I mean, system. So CPU, of course, you do not need to make another analogy, right? You do not need to compare it differently. Your CPU is basically you can compare it to brain. But what about the, I mean, the memory part, right? So see, in brain, actually, you will be storing something, right? Now you have two types of storage. One is long-term storage, right? Long-term memory you say, right? So that's also called subconscious memory, right? That's also, that is long-term memory. Like you will remember about someone, right? Like if take example here, you are watching this video now. Now something you will remember, right? You remember for a long time from here, right? From this video, you remember for a long time something, right? So that will be kept in your subconscious mind. That is long-term memory. But there are many things that you will forget here, right? So that's a part of conscious thought, right? You are listening to me here, but you will forget a lot of things, right? So that's your conscious mind here, right? So of course, you take the example, your subconscious mind or long-term memory that you keep in the brain, right? So that is stored there is your hard disk. That's for long-term and like permanent, you store it permanently. But whatever you forget easily, right? So that's example of RAM. So RAM is like temporary storage. It will forget after some time. So if your system is there, if you store something in your RAM, if you switch off the system, everything will be removed from the RAM, but it will not be removed from the hard disk. So it's similar in case of here also. In brain, your conscious thought, right? The thoughts you are having now while listening to me, watching this video. So you will forget most of this, right? So that's your conscious mind. You will forget that. So that's example of human system. Another important part I will say is motherboard. Okay, let me tell you one thing that this video will be long, so have some patience on this. So this video will be a bit long. I need to explain a lot of things about computer science because I'm starting from very basics there, so it will take some time. So next one is motherboard. So of course, this is again a hardware device. You cannot see it, but this is the biggest part of the system. In the computer system, it is the biggest part. And when I compare to the human system also, what is the human equivalent of this? That's also the biggest part of your body. I will go on that after some time. So this motherboard provides connection between CPU, memory, input and output. So of course you have CPU, you have memory, you have input output devices, but they also need to communicate between each other, right? So you need to communicate, connect them like all of these, right? So they are connected with the help of motherboard. So you have like a lot of wires and everything, right? So you can see in terms of human, it's your nervous system, right? You have a lot of nerves, right, going on, right? And all of these nerves are connecting to your brain, right? So that's important here. Like brain, through brain, you are connecting to every organ on your human body, right? Through this. Similarly, using motherboard, from the CPU, everything can be connected. And this is the diagram for this motherboard. If you see a lot of wires there, right? Everything connected to each other. You have the fan also there, but there are many other devices also here. This is one of the important, I will say, part of the system. If you have this, this is one of the, I will say, biggest part of the system on your computer system. Okay, I think I have gone through all of this, but now let me discuss like what is a computer, right? I have discussed about all of this, like what are input devices, output devices, everything, but I haven't discussed what is computer. So computer is just a machine if you think, like it's a computer is a machine that takes input, execute instructions and produce output. So your computer will always take inputs from you, right? It does not have to be always you. It also takes input from a lot of programs that's running inside the system, but it normally takes some input. It will execute that. So this input will be some instruction, right? And in the CPU, which is the brain of the system, computer system, it will execute those instructions. After executing, it will give you an output. Simple example will be like if you give an input to add two numbers, right? It will take that input, two numbers. It will add that number that execute. It will CPU will basically add the numbers and it will give you the output to you. So that is typical example. Now this instructions, right? It can be like logical or arithmetic, right? So it also CPU also like makes logical decisions. Like if in the programming, it's called if-else statement. Like where you want to go this way or where you want to go to that way, right? The decision making that also is done by CPU. Also arithmetic is already important, like multiplication, division, everything is done by CPU. Now instructions are normally what happens is provided by a program. So that's where programming comes in. You need to, through CPU, you need to provide instructions. Now how will you provide instructions to the CPU? You will write some program and provide instructions. That's where programming comes. Now any machine that can compute is a computer. So, okay, now you will think that only laptop is a computer, right? Other things like mobile is not a computer. No, you are wrong actually. So anything that can compute. What do you mean by compute? Anything that can take input, execute instructions, and give you output is basically a computer. It can be mobile, it can be laptop, it can be desktop, it can be even your watch itself, right? Digital watch or any watch itself, right? That can also be a type of computer. Okay, let me show you some examples of types of computer. Of course, personal computers is one example, desktop, laptop is there, mobiles is there, but there are some other examples. Let me show you that. So these servers are one example of that. So you would have heard servers in your day-to-day life, maybe, right? It's not this servers, people say like server went down, server is up, right? So what do you mean by servers? So these servers are very important. So you are actually on some laptop, you are working on some laptop, but think about companies like Google, Facebook, right? So I told you, Facebook, Google, everything is just a program that is running somewhere on the earth, right? That program is running somewhere on the earth. Now think about this. Will they run their program on some, laptop like yours? They will not, right? Where they will run this? They will run that on servers. So these servers are normally, you have data centers, right? So in data centers, you have a lot of servers. You can see the data centers photo here. This is the photo of data centers. Like this is a single server here, if you see. And in data centers, you will have like multiple servers, a lot of servers. On this, the code of Facebook, Google.com, YouTube.com, the code of them are running. And when you type google.com on your mobile or laptop, your request goes to this server, which are running somewhere else in US or Europe or some other countries or continent, right? They are running there. And then so basically your system fetches this data from there and sends back the response to you that you see on your web browser or Chrome. Those are servers. They are very powerful servers, like they are very fast. So these servers do not have those input devices like keyboard, mouse, monitor, everything. They do not have, because they are not meant for user interaction, like physical user interaction. They are meant for just being there in the data center and running some program for you, like for serving you. When you open facebook.com, it should help in, it should run the program of facebook.com and give you data of that. Now, other than, you also have supercomputers. I mean, that there are different types of computers. Like supercomputers are also kind of servers, if you think, but these are very powerful systems. These are not like, I mean, servers are also powerful, I'm not telling, but supercomputers are more powerful than that. Like supercomputers can do some computation very fast. And servers normally have limitation of how much memory they can have, how many CPUs they can have. But supercomputers normally do not have any limitation on that. They can like they can have a lot of CPUs, they can have a lot of memory, and they can do the calculation very fast, very fast. I mean, like, and I will ask you to learn about what supercomputers can do. Actually, you will be like surprised by what things supercomputers can do. And at last, there's microcontrollers. Like, see your mobile phones, right? See, today, I will say internet, right, is everywhere. Internet devices are everywhere. It's there on your washing machine, it's there on your TV, it's there in the fridge itself, right? It's in your bulb. I mean, internet is everywhere. I mean, internet devices, if you say, right, it's everywhere. So you have microcontrollers. So these are very small actually, right? So normally if you see the central processing unit, right, CPU chip, those may be big, but microcontroller, and if I told you motherboard also, right, motherboard is very large, but the microcontroller is very small, right? So if you want to maybe use computing in very small devices, right? So let's say if you want to use computing in your watch itself or in your car itself, then you can use microcontrollers. So this is also powerful. Like this is also like a CPU. This can also do a lot of calculations. This can also do logical and arithmetic calculations. But this is typically smaller in size than your typical CPU. Okay, now this is very important. I mean, I told you about all the devices that we have, input, output, everything, how many types of computers we have. And from next time when you hear computer, do not only think about your system, I mean laptop or desktop. Think also about mobiles and all your internet devices you have. Like they all are computing something. They are executing some instructions. So think about them also. When you are driving car, think about the device you have in your car, right? That is, I mean, through which you can connect to internet and everything. So there is that's also a computer actually. Now, how to talk to computer? So understanding how to talk to computer is very important. So that's what programming is for, right? But okay, you write the program, but how do you actually communicate, right? I will explain that in this part here. So think about human beings, right? How do you communicate to other human beings? Of course, you use different languages. Maybe you use Hindi, use English, right? You use French. So you use different languages for communication between human beings. But of course, computer is not a human being, right? You cannot use the same English or Hindi to communicate with a computer. So you need some different language here. Now, can the computer understand your language? Of course, no. They cannot understand English, Hindi. I mean, if you tell them like, computer, do this for me, no, they will not do that. I mean, if you tell. Of course, you have Alexa and all today. Like you tell them they can do, but typically your system will not do anything if you tell them. Now, the language that the computer understands is binary. It's 0 or 1. So what is binary? It's like binary can take two values, either 0 or either 1. That's why the name binary. Now computer, so when I'm telling you computer, actually it's the CPU, because CPU is the brain which actually executes your program. So you know, when I'm telling you that you want to talk to computer system, you will talk to the CPU mostly, because that's the brain. You will talk to them, to the CPU. Now CPU understands only 0 and 1. It does not understand English, Hindi, French, anything. It doesn't understand those languages. It will only understand 0 and 1. It's like on and off. So you have bulb, right? So let's take example of bulb. When you on the bulb, right? When the bulb is lightning, right? So that's kind of on. When you basically switch off, right? It's kind of off. So Similar example, one means on and 0 means off. This you can take an example of a simple bulb. Okay, now understand what is binary. Understanding binary is very important, I will say, if you want to study. I mean, if you go to any subjects in computer science, binary is everywhere. I mean, binary is like language of computer, right? It's everywhere. Now see, in traditional time, we have like different systems of counting. Like you have tally marks, you have right. For one, you do like one tally mark, right? Like one. For two, you do two. For three, you do three, right? For four, you do four marks. For five, you do four and cross this, right? So similarly, for six, you keep on doing this. But this is not very easy. Like if you have number 9900, right? It becomes tough to represent through tally marks. Then of course we discover decimals. That's quite easy. Through the use of like 0 to 9, right? You typically use 0 to 9. Through this, you can represent all the numbers, right? Whatever you want. You want to represent 100, you want to represent 1 lakh, you can use just combination of 0 to 9 and you can represent all. And that's where we are very familiar with. We are very familiar with this decimal system of 0 to 9. Now, what is decimal system? If you understand closely, what is decimal system? So, if you are writing a number 70273, so what is this? So, when you tell decimal, it's like, I mean, you are saying something like 10, right? Decimal means 10, right? So, what that means is that, see, this is normally you call this as the ones place, right? This is as the tens place. This is as the hundred place. This is as the thousands place, right? This is as a 10,000 place. That's what you tell in counting, right? So of course, what this number means is that this is 3. Basically, if you write this number, this is something like 3 into 10 power 0 plus 7 into 10 power 1 plus you can do the calculation 2 into 10 power 2 plus 0 into 10 power 3 plus 7 into 10 power 4. This, if you do this calculation, that's what you will get the final number. So that's what decimal is actually, right? This is the ones place. So you need to multiply by 10 power 0. Now, if when you are at tens place, you need to multiply by 10 power 1, whatever value is there. So that's your decimal system actually. So I know you would have never thought about this, like how this number is actually generated, but this number is actually a decimal system. So you basically have to use this calculation and arrive at this number. This is called decimal system. Now, binary system is why I'm explaining decimal system is because, see, in decimal you are using the power of 10 here, right? In binary, you are just using the power of 2. That's what binary means 2. You can take two values, right? 0 or 1. In decimal, you can take how many values? You can take 10 values. That's why decimal, right? That's why you are seeing power of 10 here because you can take 10 different values. In binary, you can take only 2 values. Now, see about binary system. Now, okay, binary system I'll explain with an example, very good example. Now, how many numbers you can represent with the help of this bulb here, right? You have a switch, you have a bulb. How many numbers you can represent using this? Think about it. How many numbers you can represent? So I can say you can represent 2 numbers, 0 or 1 through this. Now you will ask how I can represent 2 numbers using this. See, when you are doing the switch on, right? The bulb will start glowing, right? So you can tell that as 1, right? So that's you can represent that when your bulb will when you are basically doing the switch on and your bulb is glowing, you can tell that as 1. Now, when you're switching off, right, and the bulb stops glowing, then you can tell it as 0. So basically 1 means on, 0 means off, right? So when you on the switch, the state number you can tell is 1. When you off the switch, the number you are telling is 0. So you can represent 2 numbers using this simple bulb here, right? Now, what if I give you 2 bulbs and 2 switch? How many numbers you can represent through this? Think about this. How many numbers you can represent? Now, how many combinations you can make? So first, I will do is first time I will do it. So think about 0 as off. As I told you, 0 is off, 1 is on, right? So what I will do first time, I will do both as off. So both of my bulb are off, right? So that means I can using 0 0. Basically, this is the number 0 0. I am telling that both the switch is off or bulbs are off. So that is one way of representing a number. Now, next time, think about how many different values you can represent using this combination, right? Now, what I will do is, I will let this bulb off, the first bulb off, but I will on the second one. So I can represent another value, right? Now, the third thing I can do is, I can on this one and off this one. Then you get the third value. What is the last combination? Of course, you do both as on. Now, using these 2 bulbs, I have represented 4 values, right? This is 1 value, this is 2, this is 3, this is 4. So that's what is your uh, binary system. So in binary you have 0 and 1. In decimal through 0 and 9, you can represent a lot of different values, right? Here you can represent again lot of values, but here you have to use only 0 and 1, not 1, 2, 3, 4 and everything. Now let me explain you like how actually like the data you give to your system, the instructions you give to your system or data you give, how they are stored and how the computer actually understands them. As I told you, computer only understands 0 and 1, right? So let me explain you that. So in computer you have the system of bit. So this 0 or 1 is called a bit, right? Then what is byte? Byte is the combination of 8 adjacent bits. So when you have 8 adjacent bits, so this is like a bit. It can take either 0 or 1. Now you have, when you have 8 bits, right, adjacent bits like 1, 2, 3, 4, 5, 6, 7, 8, then you have a byte. Similarly, you have kilobytes, megabytes, GB, you have gigabytes. Like these are like higher forms. So like 1 kilobyte is again 10 power 3 bytes. 1 megabyte will be 10 power 6 bytes, right? So it will keep going on from there. So that's how the memory is, your memory is. So let me ask you a question. So let's take this number like 101. This is in binary, right? There are 3 bits. This is there are 3 bits here, right? Now what this number represents. So this is in binary, right? But what is this number in decimal, right? What, if you want to know, what is that number? So I told you decimal how you do, right? You write 10 power 0 plus something, right? But this is not decimal, this is binary. So this will be basically 2 power 0, this will be 2 power 1, this will be 2 power 2. Now you will follow the same approach. You will basically multiply this. You will multiply this like 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1, right? Basically, I'm multiplying this with this, this with this, this with this, and summing all of this. So we'll get 2 plus 0 plus this is again 4. So this is the number 6 here, right, in decimal. So this through the binary, you see the system can understand this. So if you give 101 to the system, it will know that it's 6 there, right? It's 6. You are basically, when you are giving, let's say add, let's say I will give you a simple example of making you understand this, like how system actually understands. So system only understands binary, right? So how it will understand, let's say if you are telling system to add, you are giving instruction to the system that add 5 and 6. Let's say you are giving this example, or take simple example, maybe 5, 6. Add maybe 2 and 3, let's say. You are giving this to instruction to the system that do this for me, right? So see, now what will happen is normally there will be a memory. So everything is stored in memory, right? And the memory is formed of bits, right? So there will be various bits here. Like it depends on system to system. Like on some system it can be 16 bit. Like on some system this can be 32 bit. Some system can be 64 bit. So these are called registers actually that are very close to the. So registers are also a type of storage, type of memory that is very close to the CPU itself. If you do not understand like what a register is, it's okay. I mean that's very close to the CPU, and that actually stores all the data that the CPU requires actually. Now think about this. What will happen is for add actually there will be a separate code for this, right? In binary, because system understands binary. Let's say it's like 0110. I'm just taking an example. This is the code for add instruction, right? Now with the number 2, how you can represent in binary, right? It will be 010. This is your number 2, right? In binary, if you see, right, it's 010. What is 3? 3 is 0 1 1. Let's say this is 3, this is 2, right? I mean how I'm telling, this is the binary for this, you can verify this, right? 010, this is 2 power 0, 2 power 1, 2 power 2. Now this will be 0, this will be 0, so basically this will remain, right? So this is 2 power 1 into 1 is 2, right? Similarly for 3 it will be 011, because this is 2 power 0, right? This is 2 power 1, and this will be 0 itself. So if you sum this up, 2 power 1 into 1 plus 2 power 0 into 1, you get 3. Right now, system when you give this instruction, it will be converted into binary, right? Finally, system understands binary; it doesn't understand any other language. So it will know that okay, this is this binary code this binary code is for addition. So if you understand, okay, the user has given me a instruction to add, but it also needs to input to add, right? So it will see that, okay, here the user has given 2 in binary, and in 3, it has given other input. It will sum up this and give you the output in binary actually, which finally will be converted, of course, into the decimal, and you will see on your output. So this is how actually system works actually, right? System only understands binary. So if you want to write, give some instruction, right? I mean, of course, you have now program that actually converts that, but I will talk about that later. But let's say if you do not know any programming language, you do not have any programming language, let's say, then you have to give instructor something like this. You have to give them in binary like this, the instruction. This is a simple example. Now you will think that, okay, I understood how numbers are stored, but how alphabets are stored? I mean, data is not just the numbers, right? You have a lot of alphabets also, right? And when you are typing into PPT, you are writing a lot of English, right? Those are alphabets. Now, how alphabets are stored? You will ask me, right? So, okay, how alphabets are stored is, there is a simple trick here. Convert alphabets into numbers and store them. Numbers you can easily convert to binary, right? And store that in the memory. Similarly, convert alphabets into numbers and store them. Very easy, right? Like A, the alpha for A alphabet, the equivalent number is 65. For B, it's 66. For small a, it's 97. For small b, it's 98. And there is ASCII table actually where these mappings are stored, like what is the equivalent number for this character. So all are stored in ASCII table. Now let's move on to like how can you communicate with the computer. So will you write binary code? I mean, like what I have written here. Will you write this type of code? I mean 0, 0, 1, 1. Will you communicate like this? Of course you will not, right? It's very tough to like communicate using binary numbers. For computers, it's easy, but we do not understand binary language, right? For humans, we understand English, right? You understand French, right? So of course, you do not want to communicate in binary way to the system. Now, of course, you have like, of course, this is called, let me explain something before I go like how you can communicate with a system, like by writing programs. Before that, let me discuss like what is this language called. So the language that I was talking about, the binary language, that is called machine language, because that's the language that your machine or system understands. So that's why it's called machine language. Now, machine or CPU understand binary language, directly provide instructions in binary form old times. So when there was no programming, right, when we didn't knew any programming language, so this machine language was, I will say, the machine language programming, the programming in the form of binary actually, was used in very old times when we didn't have, like when the computer was newly invented and we didn't have any programming language. At that time, machine language was used and it was very tough. I mean, like to debug the code, to write the code, it was very tough. Like if you have instruction add 3 and 5, as I told you, I have given an example you. That's how you have to write something like this: 0, 1, 1, 0, 0, 1, 1, 0, 1, 0. You have to write the program in the form of binary itself, right? That's quite tough, right? You have to convert everything into binary and write the code. That was very tough in the old times. Nowadays, nobody uses, I mean, mostly I will say nobody uses machine language actually to write programs. Maybe a few of people use it, but mostly we do not use machine language today. Then you have another, basically these are different types of, I will tell, different ways of communicating with the system. So machine language is, of course, today also you can write the code in binary and communicate with the system. It's not an issue. If you're expert in that, do write. But that's very tough actually. Then you have assembly language code. So that's another way of communicating with the computer. So you can write that in basically as instructions. You do not have to write it in binary. You can write it as, let's say you have to add 3 and 5. We will write add 3, 5. You will write like this. Now, this is quite easier than writing the binary format. But you know that your system cannot understand this add 3 and 5, right? Your system only understands binary. So of course you need to do something, right? You need to convert this add 3, 5. That this is the assembly language code. This is called assembly language code. You need to convert this into binary. So machine cannot understand this assembly language. So this is the kind of assembly language you are giving, right? Add 3, 5, multiply 4, 5, subtract 3, 4. These are all like assembly language. Basically, you are giving the instruction in English, but system cannot understand this English, right? You have to basically the system has to convert this assembly language into machine code. Machine code is binary. That's what system understands. So in the human beings also, right? You have translator. So let's say if you do not understand their language, someone else's language, you will basically use a translator to convert your language into the language they can understand. Similarly, they will also do the same. Similarly, in a computer system, you will do the same. There is a actually a tool or program called assembler. Now this assembler, what it will do is, it will convert the assembly code to the binary code. So it will convert this add 3 and add 3, 5 to the binary code that I have shown you, right? It will convert that into the binary. Now this binary code, the system can understand. So when you write a program in assembly language, you will use a assembler, that is a program. The assembler will convert your assembly language code into binary code, and that binary code then can run on the system. But of course, again, understand this. This is also very tough, right? Writing the instruction itself, okay, easier than writing the binary code or the machine code, but it's still very tough, right? Writing add, 3, 5, multiply. Now let's move on to next part, that is low-level languages. So languages which are close to the machine are called low-level languages. So these languages are machine-friendly. So these are not human-friendly languages. So if you want to write program in these low-level languages, it will be very tough for you. Already I have given the examples of this. So the machine language and assembly language are the examples of low-level languages. So these languages are very close to the machine itself, but are not very close to the users like us. And these are dependent on the machine. These languages, these low-level languages are dependent on the machine. So if you are writing a program in one, let's say if you are writing a program, let's say in machine language, let's say you are writing in terms of binary, you are writing a program in that. Now, it is not guaranteed that if that program is running on your system, it is not guaranteed that that program will also run on some other system, because this program are dependent on the machine. Like it will run on one machine, but if the other machine is different than this machine, it may not run on the different machine. Because if CPU has a specific set of instructions, it can perform. So on your CPU, you have different CPU. Your system has different CPU than the other system. Your CPU can perform some instructions that the other system cannot, right? So that's why your program may not be able to run on the different system. And similarly, their programs also cannot run on your system. It may happen. But these languages, low-level languages, example, machine language, assembly language, as you saw, it's very tough to write and understand those languages. The language of binary and assembly languages, those are closer to the machine. They can understand, but not for us. But they are very efficient. Efficient in the sense that as the languages are very close to the system itself, they are very efficient. They are very fast. Now, let's move on to the next part. So we have low-level languages. Similarly, we have high-level languages. So these high-level languages are the languages, and these are, of course, the programming language. All of the things I am talking about, all the language are programming language. So the high-level language are like human-friendly language. It's like almost like English, right? So you can understand, and humans we can understand easily. We can write easily program in these high-level languages. It's very easy to understand. And this program can also run on multiple machines. Even if the CPU on two machines are different, these high-level programs can run on them. These are the most widely used programs because as we humans are the programmer and we understand this better. So of course, these are the most widely used programs. High-level languages are the most frequently used languages in the world. But these high-level languages, right, they are not as efficient as the low-level languages. Low-level languages are very close to the system. They are very efficient. They are very fast, but not the high-level languages. Because you need to convert these high-level languages into low-level languages first, right? Because the system understands low-level language. The machine language, it understands machine language. So you need to convert these high-level languages into low-level, and there are various reasons because of which it becomes like less efficient. I'm not going to discuss the reasons here actually, but of course you can read it online if you want to, or maybe I can discuss it in some separate video why it becomes less efficient. Some of the famous examples of high-level languages are C, C++, Java, Python. So of course I will be teaching you Python here, but there are other high-level languages also like C, C++, Java. These are very famous high-level languages. Now, how does high-level languages get converted into machine code? Machine can only understand machine code, 0 and 1. So of course you need to convert this high-level language also into machine code. Let's see how this can be done. So of course, again, you need to use translators, right? Similar, if you remember in the assembly language code, it was different than the machine code. So you were using a translator called assembler to convert that assembly code into machine code. Similarly, here also you will use translators. So you have two different types of translators to convert your high-level languages into machine code. So one is compiler, one is interpreter. So let's understand the difference between these two. Now, everything is programmable. The assembler was a program. The compiler is also a program. Like a compiler is a program that converts high-level language code to machine code in one go. This is very important. This line, one go, is very important. So let's say if you have written this program, so you have different lines of program. This is your program, let's say. When you give this program to a compiler it will convert this to a like 0101 something. It will convert 01010101. It will convert that to machine code in one go. Right? It will take the whole program. Like let's say you have 100 lines of code here. It will take those 100 lines and convert all the 100 lines into machine code at one go. Right? This is one of the important subject in computer science. It's a very important subject. Compiler design is very important subject. Like how your code in level languages, high level language gets converted into low level languages. That is very important. Like how this algorithm and like how this is actually done. That is very important subject in computer science. Now you see high level program you have compiler which will compile it, basically convert that into machine code. Then your machine code will run on the CPU because CPU understands machine code. Now what if you want to make some changes? Now what if you want to make some changes to the program? Now you need to compile again because all the program gets compiled at once. Now you have made some changes. So you need to compile again. It will again get converted into 0 and 1 again, the 0, 1 program, machine code program. Then again you can run it. That's what happens. This is very fast and efficient. I mean, this is not as fast and efficient as the machine code or the assembly code, but still compared to the interpreted language that I will discuss now after some time, it is more efficient than the interpreted language. Now, some of the famous examples of compiled language are C, C++, Java. These are compiled languages. These are very fast. Now, the difference in interpreters and compilers, right? Where the difference lies is this. See this line. These interpreters run through a program line by line and convert them to machine code. So what happens in this, when you have interpreted program, so you can have a compiled program or an interpreted program. When you have an interpreted program, so both are basically your high level language program, right? So when you are using interpreters, what will happen is something like this. So you have this program again. There are multiple lines here. Now, when you're the interpreter, what will happen? This is let's say line 1, 2, 3, 4, 5, let's say, right? So when you basically run this program, now when your program is at line 1, the interpreter will convert this line 1 into machine code. When you go to line 2, it will again convert line 2 into machine code. So you understand the difference. Here also the program gets converted into the machine code, but not in the same way. In compile program or using compiler, the program at one go gets converted into machine code at one go. Here line by line it happens. First line is converted. Then when you are running the program, when you go to the second line, then second line gets converted, then third line gets converted, it goes on. This I have given the example here. Now what if you want to make the changes? So you can just make the changes in the program, nothing happens. You can make the change in the program. And if you have not, I mean, understand this, if you have and in the case of compilers, if you made a change in the program, you need to compile it again. Here it's not, you don't have compiler. You are going line by line, so just make the changes, run again. It's quite easy here. Now some of the famous language of, this is slower than the compiled language. Like this is slower than your C, C++, Java, which are compiled language. This interpreted language are slower than that. The famous interpreted languages are Python, PHP, JavaScript, Ruby. So basically the languages which use compilers are called compiled languages. So these are the high level languages which are using compiler to convert your code, the high level code to machine code. Now interpreters or interpreted programming languages are those languages which use interpreters to convert this high level language code into machine code. Now this is all done till programming and everything. I am done with programming at least. All the programming things I have covered, like how machine understands and compiler everything, right? So basically understand this, you have like low level languages, you have two, right? You have machine code, you have assembly language, right? You have two of these two are low level languages. And in assembly language, you are using a program called assembler to convert this assembly program into machine code, because the main aim is to convert every program into machine code. Now you have high level language. Now these are closer to the machine and machine understands better. High level languages are like closer to us, and you have two types of languages here also. You have compiled language and you have interpreted language. Now I have explained already the difference between these two. Now let's move on to data structure. So data structure is also a very important part of computer science. So also understand this. I will just give a brief overview of this. Now see, you have data, but there should be a way in which a data is stored on the system, right? So that's data structures. So you have some structure through which, I mean, there is some structure which you follow actually to store the data on the system. Take example, like different types of data are there. Like you can have integer, right? Integer data. You can have a string data like my name, Shivam, it's a string data. You can have a list like 1, 2, 3, right? This is a list basically. You have a list of maybe a list of cities you have, a list of routes you have, right? These are lists here. Now these are different types of data and these are stored in different ways on the computer system. That's why data structure becomes important. Now you will see that why not store all the data in same way, right? Now you can store, I mean, you can store the data, all the data in same way, but what will happen is it will be, so you also need the CPU also needs to fetch this data from the main memory. It needs to fetch this data from the main memory. Now, if you store all this data in same way, then for the CPU, it will become very difficult to fetch this because the main aim is to fetch this data from the main memory and process this data, right? Now it will become very tough for the system in this. Now let's say if you have stored three numbers, you have like two cases here. You can store something like you can use A, B, C and store three values 1, 2, 3. Or you can use a list and you can store 1, 2, 3. Now it will make a lot of difference if you store this way versus if you store this way. It will make a lot of difference in searching, sorting and everything. It will make a lot of difference. And accessing this data, also the time required, it will make a lot of difference here. So I'm not going into deep of this here, data structures here, but understand this, like data structures are very important part of computer science because the way you store the data in main memory, it makes a lot of difference. Understand this point. When I cover data structures later on, I will, through examples, I will show you how the difference is coming. Now, next one is algorithms. This is also a very important part of computer science. So see, understand this. A program is a set of instructions. So a program you're writing, it's a set of instructions, as I told you before. Now, this set of instructions can be written in different ways. I will give you an example here. Think about this. I have a book here. Right? This is a book here, right? This book is there. Now, I have to search a page number in this book. So basically, it's like instruction basically, right? I am also performing an algorithm here. See here, this is a real life example of how we use algorithm. Now I have to, let's say, search page number 100 in this book. Now, how I can go is I can maybe start searching from the first page itself. I can open the first page and I can go on right from here. Sorry, I can go on from here. Right, I can start like 1, 2, 3. I can go on like here. Right, but you know it will take a lot of time. Another algorithm I can do is algorithm is basically the way in which you are executing or in which you are providing the instruction. So here the instruction is like start from the first page and go on, keep on going on. Another algorithm can be start from the last page, right? I start from the last page and keep on going from the last one by one, right? Now this is another algorithm. Another a better algorithm can be I start right from the maybe from the let's say from the middle layer. I start from the middle layer and I see that page number is there around 289. Now you know that which side you have to move to find the page number 100, right? So of course here if I have page number 289, I will move backwards, right? I will move backwards and again I will basically, now I will ignore this part, the forward part after page number 289. I will move backward and again I will divide the backward part into half. Maybe I will just do something like this, going backwards. And now I'm at page number 117. See, I got closer to page number 100. Similarly, I can again divide the backward part again into two halves again. I will divide into middle and keep searching that. So that is the kind of algorithm if you see here, right? I mean, all three are different algorithms and the efficiency, I mean, the time taken for like searching using all these three algorithms will be different. You know this. When I am going from right starting or the end, it will take a lot of time. But if I just open the middle page and ignore one part, again go this side, open the middle page, again ignore one more part, it will take less time for me. So that's where our algorithms comes. It's a sequence of instructions to solve a problem. Now you have efficient versus non-efficient. Like for me, starting from beginning or at the end is not very efficient, but starting from the middle is very efficient algorithm. This is also closely related to data structures. So data structures and algorithm, people will say data structures and algorithm because both are connected to each other. So I'm not going to explain that how it's connected, but of course when I go to data structure and algorithm, I will explain you. This is again an important subject in computer science. Now let's look at another important subject in computer science, that is operating systems. So operating systems is also a program actually. Operating system is also a program that acts as an interface between the user and the computer hardware. So a user cannot directly communicate with the hardware. So if you have to communicate with the hardware, you need to go through the operating system because that acts as an interface. So your example of operating system is Windows itself. Windows is the operating system. Now, this operating system helps in the communication with the hardware devices. So think about you are writing a program that wants to write to some file. My file will typically be stored on the disk, and your disk is a hardware device. Now, if a program wants to write to this file in the disk, if your program wants to write something into this file, then it has to go through the operating system. It has to ask operating system that okay, operating system, do me one favor, write this content right into this file. So operating system will do that. This also manages the resources of a system like CPU, main memory, everything. So operating system like Windows, it will manage like all the main memory you have, RAM, all the CPU that you have in the system. Operating system will manage it, and it's like a program that runs the program. So when you are running a program, as I told you in compiled language, if you are running a program, that program will be run by operating system. That is another program. So basically, a program to run a program. Not get confused by this, but you have a program that operating system helps in running, and operating system is also a program actually that helps in managing the resources. It helps in communicating like your program to the hardware, right? Everything else is done by operating system. Now, when you double click on a program like Google Chrome you have on your desktop, you double click it. Now, CPU is dumb. CPU will not run any program by default. It has to be given some instructions to run, right? I mean, I'm not saying CPU is dumb. CPU is very intelligent, but it does not do anything on its own. You have to fetch it instruction. You have to give it, you have to give the instruction to the CPU, and then CPU will run it. So that now someone needs to tell CPU to run the instruction, and also someone needs to provide memory for the program to run. Now who is this someone? This someone is operating system, which helps the program to run on the CPU and also gives memory and CPU to the program. Now next one is the computer networking. This is also a very important part of, I will say, computer science. Another, I will say, a very interesting subject in computer science. And computer networking is everywhere. I mean, you are using the internet, right? So you are basically using computer networking itself when you are using the internet. Now, what happens when you type google.com in Chrome and press enter? When you type google.com in your Chrome browser, press enter, then what happens? I mean, you do not know what happens actually. You get some Google page, I mean, right? Google search page you get, right? But actually, a lot of thing happens on the background side. On the behind scene, a lot of things happen. That's where computer networking comes in. Computer networking actually helps in like uh, transferring your data from like your system to, I told you about servers in the beginning, right? So the servers are running those program of google.com. So it will help in transferring the data with the help of like you have network devices are there, like routers are there, switch is there, cables are there. With the help of all of this, the computer networking actually helps in transmitting of data from one place to another. Now, of course, operating system will also help in that. So with the help of operating system as well as networking devices like routers, switch, cables, these communications are made possible. There are a lot of networking protocols. If you study computer networking subject, you will study about a lot of networking protocols. That means there are a lot of rules which this device, right, network devices and operating system needs to follow in order to communicate this data. This is another important subject in computer science. Now let's connect all of this together just to give you an example. So let's connect this all of this. So see what you do is you normally as a user you will write a program, and you will write a program in high level language like C, C++, Python, Java, all of this. Now this high level languages needs to be converted into the machine language. So either it can be, I mean, compiled and converted, or it can be like you can use either a compiler to convert this, or either you can use an interpreter to convert this. Then once this is converted into the machine code, then you can run your program. So once you run your program, then operating system kicks in. Now operating system will provide CPU and memory for your program, and it will also run your program on the CPU. Basically, it will tell the CPU that run these instructions. Now, in between the program, you may also use some networking calls. I mean, let's say if you need to download a file from internet, if you want to download a file from the internet in your program, in that you are also using computer networking because you are making some internet calls. So there you are making networking. So all of these are connected all together. That's why it's important to study all of these subjects of computer science. And also in your program, I forgot to tell you, you will also write a lot of algorithms and data structures. So in your program itself, you will use a lot of data structures and algorithm. So all of these are connected together if you see here. Now there are some other important subjects also. And I will say this like, see, I will say programming, data structures, algorithms, operating system, computer networking, compiler design. These are some of the important subjects in computer science that I also studied in the college, and I will say you should also study mostly. And at least if you leave, okay, you can leave compiler design if you want to, maybe if you do not want to understand, but at least focus on these 5 subjects, at least have a basic understanding of. So focus more on programming, data structures, and algorithm. These 3 are very core to computer science, but also focus like you should have some knowledge, good knowledge of OS and networking also. Some other like topic subjects which are important in computer science are computer architecture, like understanding the architecture of the computer itself. Then artificial intelligence, machine learning, cryptography, database, theory of computation. Like these are some of the important subjects. Like I also took some of these subjects in my college. But I will say these are not, I will say very important. Like you can, once you form a good basic of this programming, data structure, algorithm, you can get all of this. Like if you want to study, you can take these subjects also. It's not very tough. Now, what's next? What's in the next video? So, I think if you have, I hope that you would have understood the basics of computer science from this video. Now, at least you understand like what are the input device, what are output device, what is actually a program, what is CPU, what is memory, like what are different types of program, low level programming, high level programming, interpreter, assembler, then compiler, then what is operating system, what is data structure, what is algorithm. At least you understand a basic of all of this. That's what I want. So if somebody asks you like what is operating system, you should be able to tell that okay, operating system is like it helps in running the program. It provides resources and CPU to the program. Something like this. At least you understand this. If somebody asks you what is data structure, so you can tell them that of course program consists of data. So you need to store this data, right? But this data are different. Like some data, if you store all the data in same format, it will not be very efficient. So that's why data structures are there. Algorithms, I gave an example of searching in a book. Like, so you should understand something like this. At least you have a concept of all of this, that, okay, these are some important subjects. But once you go like, okay, you should have an overview of this. Now, when you go to study programming, when you go to study data structures, when you go to study algorithms, at that time, you will get a detailed knowledge of all of this when you study those in details. So that's what my intention from this video was, that you should understand what are the different subjects of computer science and at least know at least 3 or 4 lines about all of this. Like you can tell to someone what this is at least. So I hope you would have understood this, and please do tell me in the comments like where you able to understand these basics of computer science, because I am making these videos for, I mean, anyone, like if anyone does not know any programming, they should just be able to understand these all stuffs. So do tell me in the comments and provide me feedback on this. So that's all on this video, and I will start. I'm getting started with Python. I will start in the next video. Thank you.